now that we've talked about the different angle measures and where different angles lie, right, in which quadrants, we can try to sketch some of these angles in standard position. All right. Now I believe with this problem here, there's 8 angles, and I believe 2 of them are going to be in each quadrant. So 2 in the first, 2 in the second, 2 in the third, and 2 in the fourth. Right. So we'll start with the degree ones because those are the easier ones in general for people to do. Right. So 120 degrees first. And again, you're sketching these in standard position. So whenever you're sketching in standard position, you need to draw a set of axes because the initial side is the positive x-axis. Okay, so 120 degrees. I would start at the positive x-axis, and it's positive, so I'm rotating counterclockwise. That would be 90, and then another 30. So not quite halfway between 90 and 180 would be your 120 degree angle. Right? And in general, you want to try to sketch these as accurately as possible. Like, you don't want to make this down there because then it would be closer to 180 than it is to 90. And 120 is clearly closer to 90 than it is to 180. So you want to try to draw it accurately. All right? So this little space in here should only be 30 degrees. Right? 30 more than 90. Okay? So now 210 degrees, where does this fall? Well, 210, and again, just count by 90s. That's probably the easiest way to do it. That's 90, that's 180, and then I need 30 more to get to 210. So again, not quite halfway between 180 and 270. So that would be your 210 degree angle. All right? And then 300 degrees, count by 90s, starting, initial side, there's 90, 180, 270, and actually again another 30. So not quite halfway between 270 and 360. That would be your 300 degree angle. And then finally 225, which would be 90, 180, and then from 180 to 225 is actually 45. So this one is smack dab in the middle of 180 and 270. So try to make it as close to the middle as you can, and that would be 225 degrees. Okay, so those are my 4 degree measured angles in standard position. So I've sketched my degree measured angles in standard position. Now I'm going to sketch my radian measured angles in standard position. So we have 3 pi over 4, pi over 4, 11 pi over 6, and pi over 6. So 3 pi over 4 radians, and again, this is where it's not natural probably for you, at least at this point. So what you can do if you really want to, I'm not going to do it this way, but what you can really do is eventually you can just convert these into degrees first, then sketch them where they belong, and then just write the angle measure in radians, right? So like 3 pi over 4 would be 135 degrees, so you would just sketch 135 degrees, right? But again, we want to try to get you at least into the habit a little bit of thinking in terms of radians, right? So in terms of radians, rather than going in increments of 90 per quadrant, right, you're actually going in increments of pi over 2, so which is a half pi, and 3 pi over 4 is really 3/4 pi. So where does 3/4 land? If this is a half of a pi, right, half of a pi, right, 3/4 of a pi would be halfway between a half and 1 whole pi, right? So right here, smack dab in the middle, would be 3 pi over 4 radians. Okay? Now pi over 4 is easy because we just did 3 pi over 4, right? So 3 pi over 4 we said was 3/4 of a pi. Pi over 4 is 1/4 of a pi. And if each quadrant is a half a pi, a quarter of a pi would just be halfway up there, right? Because up here would be a half a pi, so a half of that is a quarter of a pi. So there's your quarter pi, or pi over 4 radians. All right. Now 11 pi over 6, this is a harder one to think about probably because, see, sometimes mixed numbers help here. 11 over 6 is really 1 and 5/6. So this is actually 1 and 5/6 pi. And we know that all the way around is 2 pi, and 3/4 of the way around is 1 1/2. So 1 and 5/6 is actually almost one full time around. So it's going to be pretty close to a full circle, right? It's just 1/6 pi shy of a full circle. So if this is a half pi, 1 pi, 1 1/2 pi, which is 1 and 3/6 pi, there's 4/6, and then there's 5/6. So that right there is actually 1 and 5/6 pi, which is 11 pi over 6 radians. Okay? And then pi over 6 is very small angle again. So pi over 6, again, if you think in terms of each quadrant is a half a pi, which is in terms of sixths, it's 3/6. So the full quadrant would be 3/6 pi. This is 1/6 pi. So 1/6 is only going to be up here a third of the way up. So pi over 6 is actually something like that. That would be pi over 6 radians. And again, why? Because then that would be 2 pi over 6, and then this would be 3 pi over 6, which is a half, right? So I was just taking 1/3 of a half pi, which is actually 1/6 pi. So that would be pi over 6 radians.